Okay, so me going over like modules 1.4 probably to 1.6 this video. We'll see. I got a couple of the other videos I want to make today, so I don't know how much I'm gonna do, but anyways, um, in the previous lesson we covered how to define a variable that we can use to store values. In this lesson, we'll explore how to actually put values into variables and use those values. As a reminder, here's a short snippet that first allocates a single integer variable named x. It allocates two more integer variables named y and z. Int x define an integer variable named x, int y, and z. After a variable has been defined, you can give it a value in a separate statement using the equals operator. Or, well, this is the assignment operator in C++. Oh, this process is called assignment, and the assignment operator is called the assignment operator. Okay. Int width, define an integer variable named width. Width equals 5. You can do that all in the same line, by the way. It doesn't need to be. You can just do int width equals 5 and then semicolon. I don't know what it's. I guess they want to split it up to split up declaration and definition and assignment, I guess. Define an integer variable named width. Assignment of value 5 uh into variable width. Variable width now is value 5. By default, assignment copies the value on the right hand side of the operator to the variable on the left hand side of the operator. This is called copy assignment. Here's an example where we use assignment twice. Okay, int width. Okay, it prints out the width. Assigns the width to 7, or assigns 7 to width, and then prints it out again. Okay, this prints 57. Oh, because it prints out. Yeah, okay. When we assign value 7 to variable width, the value that was there previously is overridden. Normally, variables can only hold one value at a time. Warning: one of the most common mistakes any programs make is to confuse the assignment operator with the equality operator. Equals equals assignment is used to assign a variable to a variable. Equality is used to test whether two operands are equal in value. Okay, variable initialization. One downside of assignment is that assigning a value to a just defined object requires two statements, one to define the variable and another to assign the value. These two steps can be combined when an object is defined. You can optionally give it an initial value. The process of specifying an initial value for an object is called initialization. Syntax used to initialize an object is called initializer. Informally, the initial value is often called an initializer as well. Int width, define variable width and initialize with initial value 5. Above initialization of value width, 5 is the initializer and 5 is the initial value. Key insight. Initialization provides an initial value for a variable. Think initialization. Different forms of initialization. Unlike assignment, which is comparably simple, initialization in C++ is surprisingly complex, so we'll present a simplified view here to get started. There are 5 commonly used ways to initialize variables in C++. Int a, so just initializing it, default initialization until it's initializer. Traditional initialization form. This is one I usually do. Copy initialization. Initial value after equal sign. Okay. Int c, parentheses 6. Direct initialization. Direct initialization. Initial value in parentheses. Modern initialization forms performed or preferred. Yeah, by initialization embraces direct list initialization. Okay. You may see the above form is written with different spacing. For example, int d7. Whether you use extra spaces for readability or not is a matter of personal preference. Other forms of initialization include aggregate initialization. Okay, we're not going to look at the copyless initializations discussed below. Reference initialization, static initialization, constant initialization, dynamic initialization. So, okay, I honestly had no idea there was this many different ways to initialize a variable. Like, the ones that I've always used were either the braces or this one, or I guess default initialization. So I've only ever used direct list initialization, copy initialization, and default initialization. I've never used these other ones, to be honest. I don't think I probably ever will, unless I have a reason to. Related concept. We discussed the key differences between copy initialization, direct initialization, and list initialization in lessons 14.15. Well, that's about 4 million years away from us, so that's about it. Default initialization. When no initializer is provided, such as for variable a above, it's called default initialization. In most cases, default initialization performs no initialization and leaves the variable with an indeterminate value. Yeah, okay, when you make a variable, you always want to assign something to it. Okay. I'll always assign anything to it. Like you can assign null to it, zero. You just all make sure you assign something to it. Okay. When initial value is provided an equal sign, this is called copy initialization. This form is initialization was inherited from the C language. Copy initialization of, okay, we already know this shit. Much like copy assignment, this copies the value on the right hand side of the equals into the variable being created on the left side or left hand side, and the above specified variable width will be initialized with the value 5. Copy initialization has fallen out of favor in modern C++ due to being less efficient than the other forms of initialization for some complex types. However, C++17 remedied the bulk of these issues, and copy initialization is now finding new advocates. You also find it using older code, especially code ported from C, whereby developers simply think it looks more natural and is easier to read. True, this is a lot more like natural. Easy to read, I'd say. To advance reduce, copy initialization is also used whenever values are implicitly copied, such as when passing arguments to a function by value, returning from a function by value, or catching exceptions by value. When initial value is provided inside parentheses, this is called direct initialization. So yeah, I'm planning to start doing this actually. Now that I think about it, when I'm assigning values, like null and 0 to values I don't want to initialize yet. Direct initialization was initially introduced to allow for more efficient initialization for complex objects with class types, which we'll cover in a future chapter. Just like copy initialization, direct initialization has fallen out of favor in modern C++, largely due to being superseded by direct list initialization. However, direct list initialization has a few quirks on its own, and so direct initialization is often, once again, finding use in certain areas. For cases, direct initialization is also used when values are explicitly cast to another type. For example, static underscore cast. One of the reasons direct initialization has fallen out of favor is because it makes it harder to differentiate variables from functions. For example, for declaration of function x, definition of variable x with initializer 0. Function call if t is a function. Oh, that's actually a pretty good point right there. I didn't even think about that. This looks exactly like a function, doesn't it? Yeah, and yeah. T5 function call if t is a function. Direct initialization of temporary object is if t is a type. Direct list initialization and copy list initialization. Oh my god, this word, bro. I'm starting to get pissed off. The modern way to initialize objects in C++ is to use a form of initialization that makes use of curly braces. This is called a list initialization, or uniform initialization, or brace and initialize. Okay. A list initialization comes in two forms: int width bracer 5 bracer. Direct list initialization of initial value 5 into variable width preferred. Int height equals copy list initialization of initial value 6 into variable height, rarely used. Okay. Prior to introduction of list initialization, I might start using this instead. I've been using this for some things I've been doing. I only use it rarely, but when it comes to like, I don't even know when I use it, to be honest. I think I just use it sometimes. I fucking know where. I'm just stupid or something. But sometimes it just feels right. Anyways, copy initialization can be hard to differentiate from copy assignment because they both use an equals operator or assignment operator. Direct initialization can be hard to differentiate from function-related operations because they are both used parentheses. List initialization was introduced to provide a consistent initialization syntax, which is why it is sometimes called a uniform initialization. That makes it clear we're doing initialization. Key insight: when we use curly braces, we know we're creating an initializing object. Yeah. Additionally, list initialization provides a way to initialize objects with a list of values rather than a single value, which is why it is called a list initialization. Show an example of this in lesson 16.2. Instruction to standard vector and list constructors. Oh, this is gonna be a really good one to read through. Vectors are very what is it called? Very frequently used, or not. I wouldn't say frequently used, but they're used in things that are very important. Like, because the vectors are basically, what does it really matter? But I'm just gonna say anyways. They're like dynamically allocated arrays. So like as an array, you probably don't know what an array is yet, but arrays basically you can assign how many values it can store within them, or how many variables it can store within them. But with a vector, you can store as many as you want, and it'll keep on growing or shrinking depending on how many you store inside of them. So it's really good for making like entity lists and shit like that within games. If you're doing game hacking, which is obviously what we're gonna be getting onto. List initialization disallows narrowing conversions. The primary benefit of list initialization is that narrowing conversions are disallowed. This means that if you try to list initialize a variable using a value that the variable can not safely hold, the compiler is required to produce a diagnostic using error, for example. Int main. An integer can only hold non-fractional values. Int w1, as we assign 4.5 to it, but that doesn't work because it's an integer. Int w2 equals 4.5. Yeah, okay, int w3. Okay, it's all the same thing. Okay. Yeah, basically integers can't assign. It can't have floating point numbers attached to them. On line 4 of the above program, we're using a value 4.5 with the fractional component 0.5 to list initialize an integer variable which can only hold non-fractional values. Because this is narrowing conversion, the compiler is required to generate a diagnostic in such cases. Copy initialization line 6 and direct initialization line 7, but silently drop the 0.5. Initialize the variable with the value 4. This probably isn't what we want. Compiler may warn you about this issue. This list data is rarely desired, but it also may not. Note that this is a restriction on narrowing conversions. Only applies to the list initialization, not to any subsequent assignment to the variable. List initialization is the preferred form of initialization in modern C++. Oh, because list initialization does not allow us to lose data, does it? Interesting. List initialization, okay. Key insight: list initialization is generally preferred over than other initialization forms because it works in most cases and is therefore most consistent. It disallows narrowing conversions, which we normally don't want, and it supports initialization with a list of values, something we'll cover in a future lesson. Best practice: prefer direct list initialization when initializing your values variables with one or more values. Roger that. Author note: Bjorn Schrautstrup, I don't know if I'm saying that correctly, creator of C++, and Herb Stutter, C++ expert, also recommend using list initialization to initialize your variables. On C++, there are some cases where list initialization does not work as expected. We cover one such case in lesson 16.2, Introduction to Standard Vector and List Constructors. Because of such quirks, some experienced developers now advocate for using a mix of copy direct list initialization depending on the circumstance. Once you're familiar enough with the language to understand the nuances of each initialization type and the reasoning behind such recommendations, you can evaluate on your own whether you find these arguments persuasive. Value initialization and zero initialization. When a variable is initialized using empty braces, value initialization takes place. In most cases, value initialization will initialize the variable to 0 or empty. That's the more appropriate for a given type. In such cases where zeroing occurs, this is called a zero initialization. When should I initialize with 0 versus use direct initialization when you're using the initial value? Int x, direct list initialization with initial value 0. Using that value 0 here. Use value initialization when the object's value is temporary and will be replaced. Merely placing the value, that value so an explicit 0 would be meaningless. I think it's good, in my opinion, to just always assign something to it. But if you, I mean, I don't know how important that is. It's just for me, that's just what I do. It's standard practice for myself. Initialize your variables. Initialize the variables upon creation. You may eventually find cases where you want to ignore this advice for a specific reason. For example, a performance critical section of code, they use a lot of variables. It's okay as long as the choice is made deliberately. Really, content more discussion on this topic. Bjorn Schraub, creator of C++, and Herb Stutter make this recommendation here, themselves here. Explore what happens if you try to use a variable that doesn't have a well-defined value in less than 1.6. Best practice: initialize your variables upon creation. Initializing multiple variables. In the last section, we noted that it's possible to define multiple variables of the same type. Yeah, it says here, best practice to initialize your variables. So I would always initialize them. But if you, I mean, I don't know. I would say just do what the fuck they say. If best practice says to do this, then I would do that. That's what everybody else is gonna be doing, right? So when people look at your code, it'll make it easier for them to read and understand. There won't be any undefined behavior or anything of that sort. In the last section, we noted that it's impossible to define multiple variables of the same type in a single statement by separating the names with a comma. Int a and b. Create variables a and b, but do not initialize them. We also noted that the best practice is to avoid the syntax altogether. However, since you may encounter other code that uses the style, it is still useful to talk a bit more about it. No other reason than to reinforce some of the reasons you should be avoiding it. You can initialize and multiple variables defined on the same line. Which one is a common pitfall here that occurs when the programmer mistakenly tries to initialize both variables by using one initialization statement? Correct A and B initialized. Okay. In the top statement, variable A will be left uninitialized and compiler may or may not complain. If it doesn't, this is a great way to have your program intermittently crash or produce sporadic results. We'll talk more about what happens if you use initialized variables shortly. The best way to remember that this is wrong is to note that each variable can only be initialized by its own initializer. Sorry, stretching. Okay, so correct. Wrong, right into this shit. Unused initialized variable warnings. Modern compilers will typically generate warnings if a variable is initialized but not used. This is rarely desirable, and if treat warnings as errors is enabled, these warnings will be promoted to errors and cause the compilation to fail. Consider the following innocent-looking program. Int main, int x initialized to value 5 but not used anymore, return 0. Combine this with GCC and treat warnings as errors, and the following errors are noted. Function int main error unused variable x. It's an unused variable, okay, and the program fails to compile. There are few ways to fix this. The variable really is unused and you don't need it, and these options to remove the definition of x or comment it out. After all, it's not used and removing it won't affect anything. Another option is to simply use the variable somewhere. Okay, but this requires some effort to write code that uses it and has the downside of potentially changing your program behavior. The may be unused attribute is C++17. In some cases, neither of the above options are desirable. Consider the case that where we have a set of math/physics values that we use in many different programs. Here's some math/physics values that we copy pasted from somewhere else. So we assign pi the value of 3.14, okay, gravity 9.8, phi 1.61, okay, whatever. And we don't use gravity. The compiler will likely complain about gravity being unused, okay. If we use these values a lot, we will probably have these saved somewhere, copy paste, so import them all together. Now, in any program where we don't use all these values, the compiler will likely complain about each variable that isn't actually used. In some above example, we could easily just remove the definition of gravity, but what if there were 20 or 30 variables instead of 3? And what if we use it multiple places? Go to the list. Variables to remove / comment out the unused ones takes time and energy, and later if we need one that we previously removed, we have to spend more time and energy to go back and re-add / and comment it. To address such cases, C++17 introduced the maybe unused attribute, which allows us to tell the compiler that we're okay with the variable being unused. The compiler will not generate unused variable warnings. Such variables, the following program should generate no warnings or no warnings / errors. I didn't know that, to be honest. I had no idea that's the thing. Additionally, the compiler will likely optimize these variables out of the program so they have no performance impact. The maybe unused attribute should only be applied selectively to variables that have a specific and legitimate reason for being unused. For example, because you need a list of name values, but which specific values are actually used in a given program may vary. Others note in future lessons will often define variables we don't use again. We will demonstrate the syntax for certain concepts, making use of maybe unused allows us to do so without compilation warnings or errors. What is the difference between initialization and assignment? Difference between initialization and assignment. I think assignment is you copying the value to your variable. I think that's what assignment is. Initialization is creating the variable with the value of that, I think. I can't remember exactly. Initialization gives a variable initial value at the point where it's created. True that. That's basically what I said. Assignment gives a variable a value at some point after the variable is created. Okay, it's not exactly what I said. I said assignment is when you copy a value over to it, which I guess that also makes what I said true, but yeah. And what form of initialization should you prefer when you want to initialize a variable with specific value? Pretty sure it's direct list initialization is the one we've been told to be using. Direct list initialization. Direct list initialization, okay, which is where you use debracers. What are the default initialization and value initialization? What is the behavior of each? Why should you prefer? The default initialization and value initialization. I don't behavior of each. I know default initialization is when hmm honestly I don't know, bro. What would be the default? What would be the difference between these? What is the behavior of each? I just know that default initialization is when you create the value, it already or when you create the variable, it has the value already initialized when you create it. You don't have to assign it anything. I think default initialization is when you don't have a value assigned to it, and value initialization is when you assign a value to it, like 0 or something along those lines. If you don't assign a value, and you have to assign it later. I think you should prefer value initialization. When a variable initialization has no initializer and x, in this case the variable is left with an empty value. Okay, yeah, I was right. Okay, cool. Let me see how long this is gonna be going on for. 21 minutes? Okay. I'm gonna call it there, then I'm fucking tired. Alright, thank you for watching. Next video, I'm gonna try to do it tomorrow or the day after that, we'll see. I'm a pretty busy guy. Appreciate you for watching.